Alright, this is our test prep problems solutions, part 2. Second or third topic here, looking at ratios and angles, where the various ratios are positive and negative. Let's make a bit of space here first for some of these. Anyways, first thing here, looking at where sine is negative. If you think about the circular definitions of the trig functions. Okay, so if we have an angle somewhere here, so let's just draw it in quadrant 2, but it doesn't matter where you draw it because the definitions are the same, right? If that's theta, you have that sine of theta is, let's write it over here actually. Sine of theta is whatever if you have a point on this arm here somewhere, it doesn't matter if that arm continues, but if that's your point, x and y coordinates, and then you have a radius of this circle, right? So if we imagine this circle here, imagine a circle that passes through that, no, not that. Let's try again for a circle. No, let's try again. Well, let me make it and then we'll move it to the right place. How about that? Okay, so let's say that's more or less a circle that passes through there. You have x, y, and then you have the radius of the circle, which I already have written on there. The definition of sine is whatever the y coordinate is, this, divided by the radius, y coordinate divided by radius. If you're looking at quadrant 1 and 2, right up here, that's where the y coordinate is positive above the axis. Okay, y coordinate's positive, so that's positive. Radius of the circle is always positive anywhere around. This is always positive. Alright, so above the axis, the sign is positive. Below the axis, quadrant 3 and 4, it's going to be negative. Alright, because now this thing is negative, the y coordinate. Below the axis, this y coordinate is negative. So you got a negative number divided by a positive number. It means your sine ratio is going to be negative in quadrant 3 and 4. Okay? Same logic follows for the next question here, which maybe we can just keep our same picture here. If we get rid of our highlighting here. Let's move this out of the way. That's our first one. Let's take that, move it up there. All right. So we're looking at this one now. Where's tangent negative? Or sorry, where's tangent positive? If we have that same picture, regardless of what quadrant you're in here, the tangent ratio is the y coordinate divided by the x coordinate. All right. This coordinate divided by x. Since it relies on both of those things, you got to look at where the ratio of those, where those are the same, right? This is going to be positive. This is going to be positive where you have positive divided by positive, or you're going to have negative divided by negative. That's in quadrant 1. Okay, both the x and the y are positive over there. And in quadrant 3, x and y are both negative there. You have negative divided by a negative gives you a positive, right? Say you had the point here, -2, -4, or something like that, and you had a line that passed through there. So your angle would be all the way to there. Since you got two negatives, the tangent ratio, tangent of that, let's call that theta 2. The tangent of that angle is y coordinate, -4, -2, +2. Okay, that's the tangent ratio. So it's in quadrants 1 and 3. Third thing here, how can you decide that what cosine of pi is without a calculator? Well, you can do it a couple different ways. One is you can just think about what you know about the graph of cosine. Graph of cosine looks something like this. Starts at 1, down to 0, down to -1, up to 0, and up to 1. And then it keeps going. That same pattern. 0, -1, 0, 1, 0, and so on, right? And the other way as well. One cycle of that graph is from here to here. That's the part you should know, okay? You need to know what one cycle of that graph looks like. You've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right, it's divided into 4 pieces. Those are the 4 quadrants, right? It matches what you know about the sine of the cosine ratio. Cosine is positive in quadrant 1, the graph's above. Then it's negative in 2 and 3, graphs below, positive again in quadrant 4. If you want to know what the cosine of pi is, just have a look at the graph and think about it, right? There's pi, cosine's -1. Alright? The other way you can know it is just by thinking of your circular definition of the trig functions, and what the, if you have a unit circle, okay, let's say that's a unit circle. If that's a unit circle as in radius of 1, cosine of pi, this angle over here, think about what the coordinates of that point are, because that's a point on that terminal arm. Coordinates of that point, if that's a unit circle, are -1, 0. The radius is 1. So if you have, if you're looking at the cosine of pi, it's going to be your x coordinate divided by 1. Alright? And I highlighted the wrong one there. The x coordinate divided by 1. Right? X coordinate divided by 1. -1 over 1. -1. Alright? So unit circle definition just by looking at coordinates of point or getting it from the graph. Right? Next one here. Do you need a calculator to determine what sine of 2.3 is? Yes, more or less probably you do. Yes. Unless you had some kind of a table or whatever. This is not an exact value, right? It's not an exact value that's in one of those triangles, or it's not a value that you recognize from the graph. Okay, it's not an exact value from the triangles or one of the quadrant angles from the graph. So pretty much then you need to go to your calculator and work it out, right? If you're working out this is, unless you see a degree sign there, that's in radians, right? Make sure your calculator, whatever calculator you happen to be using, is in radian mode before you start. And then all you need to do is sine 2.3, gives you the ratio. Okay, it's positive. 2.3 is in quadrant 2 if you think about it, right? Okay, if you want to just kind of confirm in your head, somewhere over there, 2.3, and angle's about like that. So it makes sense, right? Sine is positive in quadrant 2. Sine of 2.3 is roughly, what did that calculator say? 0.7457. Oops. Alright, next. Decide if tangent of 5 radians, okay? Tangent of 5 radians is positive or negative. Without a calculator, explain how you know. Same idea here. If you can figure out what quadrant that's in, then that's going to tell you what it is, right? 5 radians has got to be over here. Okay, it's got to be in quadrant 4 because halfway around's pi. This is 1.5 pi to there, which is again about 4.71. That's a handy number to know. If you know those 3 numbers, it'll help you out. So it's right there somewhere, right? It's in quadrant 4, as in 5 radians is in quadrant 4. 5 radians. Right? quadrant 4, therefore it is negative. Tangent's negative in quadrant 4. Evaluate cos squared of 4.2. This one, more or less, you can go to your calculator. Although it helps to recognize that this squared here means the same as, make a bit more space here first. That squared means the same as if it was written like this, cos 4.2 all squared. It's not the angle squared. You don't square the angle. It's not cos 4.2 squared. Okay, it's not that. So more or less, go to your calculator and put that in and see what you get, because 4.2 is not one of those angles you can, not from the triangle, not from the graph. Again, radian mode, cos 4.2. On this calculator, I don't need brackets around the whole thing, but you can put them in just to make sure if you want. Okay, so I definitely have that. So you can either do it all at once and do this, or of course you can go cos of 4.2 and then do that number squared. Okay, it's a negative number because that's in quadrant 3, but then when you square that negative number, you get a positive. Alright, so 2 steps or 1 step, you end up with roughly what there? 0.2404. Right, because again, it was a negative number squared. If the terminal arm of an angle theta passes through that point, okay, there's the point. What is theta? It says solve for theta, basically, right? Find the angle. Doesn't say right over here. The second part of this says, tell me what sine theta is. Write an exact value for sine theta. First part says find the angle. This says find the sine ratio for that angle. This tells you that the angle's in radians, right? Radians, angles between 0 and 2 pi, radians. So I would say it helps to draw a picture of the thing, for sure. You've got negative 4, 7, so let's say that this is negative 4, 7 up there. Somewhere up there, right? We have, let's actually draw the arm first. So there's the terminal arm somewhere there. That's probably good enough. Let's put the point on there. That's our angle. Okay, so that's theta. 7, negative 4. You can work out the missing side there, right? If you want to work out that missing side, it's going to be square root of 7 squared plus 4 squared. Right? Or in other words, what do we have here? Square root of 65. Right? Just a bit more than 8. Don't say that that's just a bit more than 8. Leave it like this. Okay? Use that as the side length of that side. Because now when you write number 1, this might be easier to write first here. We can write already that sine of theta is going to be 7 over root 65, right? Because it's y over r. Circular definition of sine is y over r. So that's one part of this. Second part first. If you want to find the angle, if you actually want to go through and find the angle, you can use any of these. You can use that one. It's probably safest to use tangent, because tangent, though, lets you just use the 2 coordinates that you're given in it with that point. So I'm going to use tangent to find it. I'm going to write here that tangent of theta is 7 over negative 4. Negative 7 over 4. If I want to find the reference angle, though, which is this little angle in here, to find the reference angle, that angle is less than 90 degrees. It's less than pi over 2. I'm going to say that that is tan inverse of positive 7 over 4. As in, don't put the negative in when you're working with your calculator to find the reference angle. Alright? Go to your calculator to find this. Again, radian mode, tan inverse, 7 over 4. I guess we could have put that in as a decimal, but there's our angle. I'm going to store that as something in here and use it again. So we got that's roughly 1.05. 1.052 or something like that. If we want to find the actual angle, then in this case it's pi, right? Because we got all the way around, subtract that, right? Subtract the reference angle. So we need to say this is pi minus theta r, which is going to be roughly equal to, we'll do it on here. I would use the pi button instead of using this, and then I stored that as x, so subtract that, 2.0899. We'll call it 2.090. 2.090. Okay, that's the angle, that's theta. Alright, that's probably enough for this one, and we'll do the rest in the next one.